Okay, y'all, this first video in a set of 4 is talking about linear and angular speed. Okay, so remember there's 2 types of speeds: linear speed, which is straight line speed, found by the formula, right? Rate or speed. In this case, let's just use the same letter, V. V equals the distance traveled divided by the time that it took you to get there. Right? That's how we find something's speed, distance over time. And then we have angular speed, which is given by the omega. And omega equals the angle that you rotate through divided by how long you rotate through it. Okay, so these are our 2 speeds. We have angular speed and we have linear speed. And how they relate, well, the linear speed is always the angular speed times the radius of the, whatever it is that's spinning around. Okay, so we can convert from linear speed to angular speed using this equation, V equals omega times R. So number 1 simply says a wheel rotates at a rate of 3,000 degrees per minute. Okay, so in 1 minute, it has a 3,000 degree rotation, right? 360 is 1 time, so it goes around a lot of times. Convert the angular speed into revolutions per hour, right? So this is just a straight up conversion problem. We know that omega is 3,000 degrees every minute. So whenever we're doing these conversion problems, we write them as fractions. Right? As per means divided by. So degrees per minute, we have degree on top and minutes on bottom. And we want to convert to revolutions per hour. Well, hopefully you know the conversion from minutes to hours. There are 60 minutes in 1 hour. Right? So that will cancel out our units of minutes. And then our second one is to convert from degrees to revolutions. And we need to know that there are 360 degrees in 1 revolution. So that's how we cancel out our degrees. Now this is just a straight multiplication problem. We multiply everything in the numerator together. So 3,000 times 60 times 1. And we divide it by everything in the denominator, which is just 360. So make sure we have a calculator to do these. That's an important part. The answer is 500 revolutions per hour. So we could write RPH if you want to for revolutions per hour, or you could write rev/hours, or you could just write revolutions per hour. But the answer is 500. So this wheel would rotate 500 times every hour if it's 3,000 degrees per minute. Okay, so that's kind of how we do these problems. Keys on the end of a string are spinning at a rate. So spinning rate, that is your omega, right? That's your angular speed. Revolutions per minute, right? That's our key that we're knowing this is linear speed. If the length of the string is 16 inches, that's your radius. What is the linear speed of the keys in miles per hour? Okay, so we have the formula V equals omega times R. So omega was 180 revolutions per minute, so 180 rev over min, times the radius, which was 16 inches. And we write it as 16 inches per every radian. Right, radian is one way that we measure angles in a circle. So 16 inches per 1 radian. Right, that's basically an arc length. We're changing it to an arc length. Okay, so there is your formula. That's all that we do is do omega times R. And now it's just a matter of converting to miles per hour. Okay, so the rest of this is all unit conversion. So once again, minutes to hours. There are 60 minutes in every hour, right? That's probably a pretty easy conversion for most of you. And then we have inches. We need to convert inches into miles. So let's first go inches to feet. There are 12 inches in 1 foot. Although I'm sure if you ask your device, it could tell you how many inches there are in 1 mile. But there are 5,280 feet in 1 mile. So I'm going to do my inches to miles conversion with 2 steps. Right? First inches to feet, and then feet to miles. And my last conversion that I have to do is this revolution and radians. Okay, I need to get rid of both of them. So I throw in my fact that there are 2 pi radians for every 1 revolution. Okay, that is a true fact, a true conversion. So now I'm left with miles in the numerator and hours in the denominator. So this becomes a big multiplication problem. I'll multiply everything on the top together, and I'll divide it by the product of everything in the bottom. Okay, and I'm going to get one answer. And that answer is 17.136 miles per hour. Okay, so those keys that you're spinning around on your finger are going about 17 miles per hour. Right? That's why they hurt when they hit you in the face or somewhere else. Anyway, okay, a bus is traveling at 50 miles per hour. That's the velocity, right? That's the linear speed of the bus. If a tire on the bus has a diameter of 4 feet, also known as a radius of 2 feet, calculate the angular speed of the tire in not feet per minute, but let's do it in revolutions per minute. How many times is it spinning around? Okay, so angular speed wouldn't ever be in feet per minute. Sorry, that's a typo. So let's do it in revolutions per minute, which is RPMs. Okay, so we want to find omega, right? We want to calculate omega. So if we're using our formula, V equals omega times R, that means angular speed omega is equal to V divided by R. Okay, so let's see how we do division with this unit conversion. So the velocity is 50 miles per hour, right? So we write it as a fraction. Times, or rather divided by 1 radian for every 2 feet. Okay, so this is how we do division, right? We, instead of putting the number in the numerator, we put the number for radius in the denominator. Okay, so rather than up here we had 16 inches per radian, right? That was multiplication. Now we're dividing, so it's radian over 2 feet, or divided by 2 feet. So there's your formula, V divided by R, or V times 1 over R. And now we have to do all the conversion to get it into feet per minute. So once again, let's do time. I know that in 1 hour, there are 60 minutes. Right, so that puts our minutes in the denominator. Miles to feet, right, we have to get rid of both our miles and our feet. So we know that there are 5,280 feet for every 1 mile. Right, that gets rid of both our units of distance. And then we have to change radians to revolutions. So I have rad on bottom, 2 pi rad for 1 revolution. And now we have to multiply. So let's do that and come back and see what our answer is going to be. 350.141 revolutions per minute. Okay, so the majority of these linear and angular velocity problems are all about converting from one unit to another. And you will have the conversion factors given to you on the test, so you don't have to worry about memorizing all of those numbers. Okay? Hope this helps. See you later. Goodbye.